Greetings once again, dear friends. I'm hoping you're satisfied with the training up to this point, and if you have any questions related to any of the topics, you can easily ask them, and we'll be happy to help you as much as we can. And we might also learn some new topics based on your questions, and we can grow and learn and help each other in our field. So now we just want to solve a couple more examples. Now let's say you have a floor here, and I'm doing this because there's an interesting point here. Let's say you have this floor here, and it can also have different shapes. It can also look like this. So we want to divide this using certain specific sizes and then cut it, just like the suspended ceiling tiles. So if you want to specify some tiles for your suspended ceiling, you can just split and cut the suspended ceiling itself. But let me just create the suspended ceiling here so we can have that in mind as well. 6 by 6, we can cut it like this, and there we go. So after that, we can open up the dynamo. So our main goal here is for you to understand the effects and powers that the dynamo has in a real project. And just don't think that you can only use the dynamo for basic and theoretical jobs. The examples that we're showing you in this pack are all practical and usable in real projects. So I'll save this for now in the files folder, and let's name it, for example, 09 dash, and we'll just remember that we don't need anything to do with the Revit old version folder. We have another goal in mind here. So the name is 09 dash splitting floors, and we can press save. So I don't want to split all of the suspended ceiling floors together at the same time. I just want to do it on the selected item. So I'll put the dynamo on manual settings, and then I'll search in the library, select model elements. Then we can open it up here, and let's say we'll select this surface. And you should also note that we need the package launchboxed in here. And you could only search for the package from up here in the older versions, but in the newer versions of the file, you need to look for the Launchbox Dynamo in the net yourself. Alright, then we can open up the Launchbox site itself. Then we can press this option, download Launchbox plus Grasshopper and Dynamo. You need to have a connection for the download, and it's about 5 megabytes. And if you have both the Grasshopper and the Dynamo installed, it will be installed automatically on both of them. But if you only have the Dynamo itself, it will give you a message saying that only Dynamo itself is installed. But if you have both the Revit and the Rhino files, it will automatically install it for both. After the installation process is complete, remember to restart the Dynamo and the Revit program. And if it's already closed itself, when you open up the program, you can see the package here in the list, the Launchbox that is listed here. So just remember to download the package before you have to use it. So after that, we'll go over to the library here and type in transaction. Alright, so then we'll open up the start package here, connect it to the model element and press run. Alright, so we get the number of the floors here, and we're only using this method because we've selected the specific floor. And in the next step, I'm going to select the area of the floor that we want. So in the library, I'll look for floor outline, and it uses the Practical Beam package. And as you may have noticed up to here, the Practical Beam package is one of the most useful ones. So I'll connect the floor element to here and hit run. Now let's see what it turns out like. Let me just change the view to here. Now I'll hit UN and open up the project units and change the format of, let's see, length to meters, 2 decimal places, and OK. Press run, disconnect these and run once again. And now it's just a bit cleaner. And you can see the effect of the units in the Dynamo. And now I'm going to convert this into polycurve. So look for polycurve.byjoin and open up the package. Connect it to here, select the floor outline curves and hide it for now, and hit run. Alright, so we got the polycurve up to here, and now we want to get the patch. So I'll go over to the library and look for by patch and open up the package. Connect it to the script and hit run. Alright, and now the next thing that we want to do is divide these and sort of isolate the different parts. So in the library, we can look for the get isoline and then connect the surface to here. The ISO direction here, and in its definition, it says when the direction equals 0, creates a U, and if it's 1, it creates a V. This same XY that we use. So I'll go over here and create a code block, open up the bracket, and tell it to move in the direction of both V and U. Then connect that to the ISO direction and press run. Alright, so we can see it here. So I'll just right click on the surface.getIsoline and put the lacing on cross product option. Press run once again, and there we go, this is fine as well. Now we want to state the number and the scale that we want to divide these. Let's say I wanted 60 centimeters by 60. So in the code block, I'll put in from 0 to 1 and by 0.6. Connect it to the parameter and press run. And let's see, this is what we get. So let's do something here. Go back to the code block and change the 1 to M, which is short for measure. And then I'll change the 0.6 to #N, which is the signifier of our number. You know what, let me just change the M to the one that was before, and then I can open up an integer slider here. So right click and search for integer and open up the package. Connect the integer slider to the code block and open up the integer settings. Put the minimum on 5 and maximum on 20. Then we'll use the slider and then press run. And there we go. This way you can adjust the parameters. And there we go. After that, I'll use the list.flatten package and connect the list to the curve here. This converts it into one particular list. And right now we need the Launchbox package. So in the library, I'll look for geometry split and open up the package here. And it's the one that says intersection. So our surface is the geometry, and for the cutting, we use the flatten here. Hit run, and all right, it's all fine up to here. And in the next part, I'm going to use the same list.flatten tool, connect it to the split geometry here to convert all of it into one list. All right. And well, let's see, after this, we'll need the perimeter. So in the library, I'll look for the surface.perimeter package. It's the one that says perimeter curves. Then I'll connect the surface to the flatten. And all right, let's see what else we can do after that. So these are fine up to this point. Let me just select the flatten and hide it and do the same with this one as well. Then select this flatten and hide that one as well. All right, do the same for this one as well, and then this one. But let's keep the rest, they might come in handy. All right, hit run now. Well, we haven't gotten the results that we wanted yet. So up to here, we've only gotten the surface inside, and that may be interesting. But let's see after that if we can use the polycurve.byjoin and curves package and connect the curve to here and press run. Then I'll connect the curve to here and press run, which gives us the integrated lines that we want. And you can see how the lines are joined together. And so after that, I'll use the floor by new geometry package. It uses the same practical beam package as well. So I'll get the outline from here and connect it to the polycurve. And then I'll connect the original element to the start transaction. There we go, and hit run. And now you can see each part of the surface area here is turned into a tile, but the first floor formation that we had in the beginning is still here. We just want to get rid of it now. So I'll use the list.create tool, add another item, and the item O is the start transaction package. It's what we get from that because we want to eliminate the first one. And for the item 1, we connect it to the floor. Hit run and let's see, it's fine up to here. Then we'll use the transaction end package that's listed here. Connect the input to the list, hit run, and there we go. We get the list here. And when you pay attention to it, we can see we only have zeros and ones. So I'll make a code block here and name it X and a 0 inside the bracket, which separates the zeros from the rest. All right, then I'll use the list create once again, just to make sure here. After that, I'll need to use the delete list of elements tool. So I'll search for it here in the library, and it uses the same practical beam package. And we also have a tool added here in the default newer version of the Revit file. Under the selection, I think we had a package added here that said delete. It's not here, so let's look in the elements. And yeah, here it is. I'll open it up and connect the list to the element, hit run, and let's see. There we go, it got rid of them. So this package is available in the 2.5 version that you're using here. But if you're working with an earlier version of the file, use the delete list of elements package that's shown here. You can see how interesting it divided the surface. And the reason that we're getting a warning here is because there are no things to be selected because we've deleted them. So deselect this and hit run, and there we go. I'll hit Ctrl Z to revert this and disconnect these and hit run. Then connect them once again, change the select option and hit run. And there you can see why I deselected this in order to keep the floor. So I'll cancel this and hit run. Then I'll select the suspended ceiling here and hit run. I think I made a mistake, so hit Ctrl Z, disconnect these and hit run. Then activate the select and connect these and hit run. All right, let's see what we have here. Hit Ctrl Z and let's go over here and disconnect the delete and press run. Then activate select and hit run. All right, so this gives us the ceiling, and well, let me see what I can do about it. So the reason that it doesn't go through with the command is because we have the floor outline curves tool here, and we don't have that for the ceiling. For the ceiling, you need to get the isolines from the surface separately, and then you can convert it into divided parts. So it's not a problem. This makes the work easier. So you can delete this and get the lines of the surface separately.